Good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. I'm Nozzle, application engineer here at KETIV and customer success manager for some of our major accounts as well. And today, joined by Jeff Perez. How's it going, Jeff?
How's it going, Nigel?
Good, good. So Jeff's one of the application engineers today, or application engineers here at KETIV, not just today. Jeff will give a little bit of background on himself. But today we're going to be going over leveraging Inventor data with AutoCAD Plant 3D. And that makes a lot of sense because we have a lot of customers who do have Inventor data, whether they build it themselves or they get it from vendors.
Or separate vendors or clients they work with.
Exactly.
In these models all the time.
Yeah, and then they need to use them in Plant, right? Yep. To be able to route piping and stuff like that.
And the thing about Plant is you kind of want to reduce these model file sizes. You kind of want to make them simplistic, and you want that transition to be as fluid as possible.
Yeah.
So we are going to be going through a workflow for that.
Yeah, you don't want to have your computer be super slow. I think that's the last thing anyone wants, Jeff, right? Especially with a lot of large, facilities equipment. That is, Jeff's going to show a pretty small assembly.
Yeah, we're going to show a fairly small assembly and how we could actually utilize these simplified models in our actual main assemblies in Inventor, and then bring these models from Inventor into Plant and use those as well.
Awesome. Cool. So if anyone has any questions during the webcast, definitely go ahead and type those into the chat panels in your respective viewing windows. And we'll go ahead and answer those during the Q&A at the end. But for now, I think I'm just going to go ahead and pass it on to Jeff over here. Great. And let's get started.
All right. So as Nigel said, I am a Plant 3D instructor here at KETIV Technologies. And we are going to go over here. So kind of for our agenda today, we are going to prepare model equipment. I'll show you guys how to minimize and simplify these model files that we have that can be done in-house, or model files that you're actually receiving from vendors. And we could actually utilize this simplifying method into our actual main assemblies. So I'll show you guys that. And then actually go from utilizing that simplified method and then importing it into Plant 3D as well. So within Inventor, I'm going to show you guys how to prepare the equipment. We're going to shrink wrap it. We're going to create a shrink wrap level detail, which is a substitution level detail in the model. And then we will remove some features to make the model even smaller file. And then I will show you the differences in file size that we are actually saving as well. And then I will actually show you guys how to publish this model, meaning I'm going to save this directly as an .adsk file. That way this file is actually going to be ran into Plant 3D. Okay, so we are going to jump into Inventor. So we're going to go right into this. Now in Inventor, I have this buffer prep skid that I am going to use. So I'm going to open this up. And now this is just a sample skid that you can find through sample projects in Inventor, and this is in 2019. Now this buffer prep skid, you can see it is a pretty intricate model. There is some frame generated skid bases, skid frame assembly right here. We do have a couple vessels in here with some piping. There's some various transmitters and some instrumentation within here as well. And to start off with this, what I'm going to do is I'm going to go ahead in here and open up this vessel right here. Now, a lot of these equipments that you are the end user or your company could actually be designing these vessels within house, or maybe you're working with a direct vendor that is providing you model files. Now, these model files are pretty intricate in size. This one's 193 total occurrences within this file. And then from what I want to do is actually minimize this file size. I actually want it to become a single part too as well. So in here, I'm going to go into my level of detail, and then I'm going to go into a new substitute shrink wrap. I'm going to be approached with this dialog box right here. Now in here, I could actually create a design view, a positional, or a level detail. I'm going to leave these as master. And then if you want to further go in here and remove parts, you could actually remove parts by size. So if you have specific part sizes that you want to remove, I could give it a number of, say, 6 inches. And you begin to see that some of these part files are being removed. In this case, I'm going to leave this alone for right now. I'm just going to make this more of a simpler model. And you could actually see the differences. If you do utilize removing parts by size, you could actually see what parts are actually being removed.
Yeah, and I see a lot of customers do that, Jeff. And sometimes they don't remove those parts, even though, you know, those parts add complexity.
Yeah.
Because they need to know the bounds of this thing.
Exactly. Now, speaking on that,
yeah,
speaking on that really quick is, so if I really wanted to, I could go into here and remove this bolting. I could remove some of these transmitters that are on these vessels as well. But in this case, when I'm bringing this model into plant, I kind of want to see these features or these parts within the model assembly in case maybe you're bringing this vessel into a tight facility. Maybe you need to route some piping around these specific areas. You could keep those in here. But if you do know that maybe you're not bound to a boundary in a assembly, you can go ahead and remove these features.
Yeah.
Now I'm going to go into this features tab right here. You get additional features that you could actually remove from the model file. We have holes, pockets, chamfers, and fillets. You could actually just completely remove all the holes or the pockets. Or if you wanted to remove holes by size, maybe there's smaller holes and that maybe this assembly has a bunch of these smaller hole features in here, you could determine a specific hole size. In this case, I'm just going to go ahead and just remove all holes entirely. I want this model file as small as possible. I'm going to go into pockets, remove pockets completely. And also I'm going to remove fillets and chamfers as well. I just want everything completely taken out. And now I could actually detect what is actually being removed in the model file. So when I select detect features, it's going to give me this bluish outline that we see right here. And it's actually going to detect what is being taken out from here. I could actually further preserve the features if I wanted to. Now I'm going to go into create. Now within create, you have, you could give this a specific part name if you want to. Now I'm just going to let this generate its standard part name, and then it's going to generate also a file location, and this is going to live within the vessel. And then you could actually change the style that you want this part to look like. You could actually maintain each solid as a solid body if you want to see all this definition. But in this case, I want this file as small as possible, like I stated, and I'm going to actually convert these into a single body. Now you get additional settings within this too. You get the opportunity to break the link if you want this to be dependent from your actual assembly. And then you could rename components, and also you get these two features, which is what I would actually turn on. It's fill all internal voids and remove all internal parts. Now what these do, it is actually removing all the parts, or maybe you have sub-assemblies or part files that live within this actual assembly that we don't need to see this in Plant 3D. So we're going to go ahead and actually completely remove these. Once I am okay with my selection, I'm going to go in and select OK. Now, right now, it's generating the shrink wrap. Now, right here, this may be typical depending on how outside resources are sending your files to you. This is telling you that you need to resolve a link. In this case, this is just a bitmap, so I'm going to click skip. And sometimes it might take a little bit depending on the file size. But now I could actually see that my shrink wrap has been generated. The file is very simple compared to the original. I remove all the features, that the fillets that you see around the head is now completely gone. I could look down to the right hand corner, and now I only see one actual occurrence in this entire model. So now that I'm actually okay with what I have done, I'm going to go ahead and save this. And then I'm going to go back into my master view, and I could actually see the differences between the two when I click back and forth on them. Now that this actual vessel lives in a assembly, I can actually activate this substitution level detail that I created in my main assembly. So when I actually go to this vessel, I could expand this and expand my representations tab, and I could actually, let's take note before I do this, is that there's 1,486 total occurrences in this model file. Now, when I activate that substitute level of detail, it dropped down to 1,294 total occurrences. So if you did this type of workflow, I could actually create a substitution level detail for all these vessels I have here. And if I really wanted to as well, I could do it for this skid frame assembly that I have here. And if you do that, you're actually making your actual model file smaller. It's going to be easier for you to actually manipulate, to create further work, or maybe you need to do more piping, because when you do tube and pipe, it does tend to slow down your system. So that's how you could actually utilize these substitution level details in your main assembly. Now I'm going to go back to my vessel that I created. Now from here, what I want to do to further prep this model file to bring into Plant 3D, I'm going to navigate to the Environments tab. In here, I need to publish this into BIM Content. And what this does, it is going to allow me to create several MEP connectors if I need to. I could author this part, and then I'm going to actually export this too. So here, I know that I'm going to rotate around really quick so I can see these two nozzles. A lot of cases, you may have nozzles that you may need to run piping to, or several other connector types. Maybe you're doing a mechanical ducting system. You could utilize these MEP connectors depending on the type of connector you need to route to. In this case, I do know that I'm working with nozzles, so I'm going to route a pipe connector. Move this dialog box over here. Now this pipe connector, what this does, it's going to work like your authoring tool in Inventor. And in here, I'm going to go ahead and select, I'm going to work with this drain nozzle down here. I'm going to select this outside face. And I do know that this is a drain nozzle. So I'm actually going to flip the direction it's coming out from. It's automatically going to generate a shape, a circle, and then it's going to generate a diameter based off the selection I chose. It's giving me 3.62. I'm going to go ahead and change this so that it pulls this property into Plant to 3 inches. I could further go through here and give it a system type. And I'll say this is a sanitary in this case. And then there's also additional properties that you could apply to this, but I'm going to leave this alone. Click apply. Okay. So now what this is telling me that I did go ahead and author this nozzle into Inventor. You could actually do this same technique for all nozzles that you have in your assemblies or part files, or even if you're receiving SAT files, step files, anything that you're getting, you could actually do this type of method. If I wanted to, I could do this vent type nozzle that I have right here, but I'm actually going to show you how to do that in Plant. So I'll leave this one alone for right now. Now from here, what I'm going to do is I'm going to go into author building components. From author building components, what this does, it's going to allow me to determine how I'm going to place this component into Plant 3D. I could, depending on how this model is constructed or how this model has been set up, this one right here is the model origin. So depending on where these origin axes are, I'm not too sure. I'm going to go with the view cube. So I could actually determine an insertion point. So by allowing me to go to view cube, I could locate an insertion point, and I'm going to specify this lower left-hand corner of the leg. Let me zoom out again really quick. And then I also have the functionality of including some properties as well. So I'm going to give it a description. I'm going to give this KETIV vessel. I'm going to give it a manufacturer. Let's say ASME. And then also I could give it a model number if I wanted to. I'll give it 1000. Now I do want to show you that this data is going to be transferred into Plant 3D. So if you do utilize this, you are going to retain this data as well. So now that I'm happy with this, I'm going to click apply. And then OK. Now that I have determined that authoring components, I'm going to go into export this. exported off my substitution. Now from here, you could say export this to several different file types, RFA if you're going to utilize Revit, or IFC, which is an AutoCAD format. But in this case, I'm going to utilize .adsk file. And then I'm going to navigate and save this on my desktop just so I could find it easier. And then it will publish and populate this export. And once this is done, I should see a report that I could view to see if my export was successful or not. And here's my translation report. So I'm going to click yes just to see, take a look at it. And it will open this into an internet browser. So I could actually scroll down and see that my export was successful. So I'll close out of this. And then I'm going to finish my BIM content. So now I actually exported that to a .adsk file. But before I move on to actually showing you how to import this .adsk file, I do want to compare the two file sizes. So in this case, I'm going to open up my File Explorer, and I have a SAT file of the original assembly. So we could actually see, where are you at? Here's a SAT file. So it's about 4.8 megabytes. And now my actual shrinkwrap.adsk file has dropped down to 1.8 megabytes. So we are saving quite a bit of space. And you could imagine that if you didn't do this, my main assembly could grow in size, and it could bog down your system.
Yeah, or you could have like multiple instances of the same thing, right?
Exactly.
It starts to multiply.
Yeah. So before I go into the Plant 3D side of it, I did want to I did show you guys how you can utilize a level detail shrink wrap within an assembly, how you could actually utilize that in your actual main assembly, make your entire assembly file smaller, and make it a little bit easier to navigate and manipulate. And then I showed you how to convert that into a BIM content, author nozzles if you need to, and then publish that as well.
Yep. And that's not just useful, like Jeff said, not for just plant, and I'll let Jeff go to his PowerPoint while he's doing this. It's useful for a regular Inventor workflow too. If you have like super huge assemblies, especially if you're getting a lot of vendor supplied parts, you might want to simplify those, right? Because you know that those vendor parts you're not gonna have to like change those for the most part. If they do change, right, it's going to be an entire component replaced possibly from the vendor, and then that whole model will change. So it's always good that, you know, if you get an assembly from your vendor, maybe shrink wrap it because you know that nothing's going to happen to it.
Now, with that too is when you are talking with your vendors and you are receiving these vendor files, it is best before you bring them in that you're moving as much of the features as possible. You want these files to be smaller when you're bringing them into Plant 3D. And you want to minimize the amount of time you take to draw this. So if you are getting the files, use them. So let's bring them into Inventor, convert them, and then utilize them as much as you can. So for importing to Plant 3D, before I go into Plant 3D side, I kind of wanted to show you that we are going to import the file. We are going to specify the insertion point of the importing the imported part file that we created. I'll show you how to author them, and then you could actually utilize these and create templates off these. So if you are receiving a ball valve that's always going to be the same and you want to utilize this forever, you can save it as a template in Plant 3D. So for that being said, I'm going to jump into Plant 3D.
And just for those of you who aren't using Plant, Jeff, do you want to explain a little bit of the difference between like regular AutoCAD and Plant and kind of the use case for this? I know that we have a lot of people who maybe haven't used Plant in the past.
So what Autodesk did is they created what is called what they're calling a one AutoCAD solution. Now, Plant 3D is a piping-based software where you could design facilities off of it. You could do major piping layouts. You could generate isometric drawings off of your piping layouts too pretty rapidly as well. Also, you get the functionality of being able to validate your models that you're creating off of the P&AD. Now, this all lives within AutoCAD, and you get the function of using your standard AutoCAD if you have that type of background. So that's pretty much how I would use it. So in Plant 3D, I have this Plant 3D drawing that I'm going to use. Now in here, under the Home tab, I am going to navigate to where it says Equipment right here. And Equipment, we have this option to convert Inventor equipment. So I'm going to select that. And then here I'm going to navigate to that .adsk file that I did create. So I'm going to select that vessel and click Open. Now it's going to tell me to select an insertion point. I do want you to notice that it is picking up the insertion point that I determined in Inventor. So I'll zoom out. And then I'll give this an insertion point of 0, 0, 0. Pretty standard, right? After that, I can determine a rotation if I want. I want to see my other nozzles that I have. So something like that. After that, you get to determine the type of equipment you have. Plant has several equipment choices that you could utilize. In this case, I know that this is a vessel, so I'm going to select a vessel. Click Select. And now this has been converted. Now, when I zoom in to this vessel, I authored this nozzle in Inventor, correct? We are seeing this little raindrop right here, this water droplet. Now, this is telling me that this nozzle is an open end, and Plant realized that this connection doesn't have an actual connection to it. So if I select this, I could actually further look into the properties of it, of the nozzle, by selecting that pencil. And then I could see that it actually brought in the size that I assigned to it in Inventor. So it is picking up a 3-inch nozzle. It's actually also picking up the location that I determined as well. I could actually change this if I want to, or I could remove it if I want to redefine a new nozzle location. But in this case, I'm going to, you know what, I'll change this into a 4-inch nozzle. And then let's change this to a 300-pound flange, which I know this drain isn't that, but we'll give you a good example here. And then I'm actually going to select the type of flange that I want this to be. This is going to be a 4-inch raised face 300. So I'll select that to activate it. And then I forgot to show you that this is assigning it a nozzle number. And this, since this is the first authored nozzle in here, it is automatically picking up N1. So I'll click Close. Now this part has been authored. So I could actually route off of this right away. Now I did save this vent nozzle that we have right here. I know it's not a vent, it's some other type of nozzle. I can author this as well in here, and I'm going to show you how to do that. So there's actually a couple different ways you could do this. I could select my equipment, and I will be able to select this add a nozzle. Or what I like to do is I just right click and go to add nozzle. After that, I'm going to specify a nozzle center point. I'm going to hold Shift, right click, so I can get into my additional O snaps, and I will select center point. And I have this center. Now, it is kind of hard to pick your actual padding, your direction of your nozzle. So what I'd like to do is go into my top view and just make sure that I am snapping aligned with my polar tracking of this nozzle and choose the right direction. Then once you select that, you'll get prompted with your nozzle authoring. Determine the location based off what I selected already. It is determining the next number that needs to be utilized, which is saying N2. I can change this to N3 if I wanted to. And then I'll go back into change type. I'll say that this is a 3-inch nozzle now. And then I'll say this is a 150 as well. I'll tell it that this is a raised face, and then I'll click close. So once I'm happy with my selection, Let me go back to my home view. And then I could actually finish authoring that. So that has been finished, and I could route piping off of that. Oh, of course that didn't like it. So I'm getting that error right here. So what I'll do is I actually will change the size. What it's telling me, it's not seeing that size in my spec, which probably should. I'll change this to a 4-inch, see if that works. Click close. Let me delete this. And it's not liking it. So I probably could just reauthor it if I really wanted to fix it. But it shouldn't be giving me this there. It's just fine. Of course, it does happen to me. So that's authoring it. Now that I do have this equipment in here, what I am going to do is show you how you could actually save this as a template. If you are receiving concept models that you feel that you could utilize throughout your projects that you don't want to spend time redrawing, you could actually save this as a template once you bring it in. So I'm going to select my equipment, and I want to generate a template off this. So I'm going to right click and go into select the equipment as a template. Now from here, it's going to prompt me to a file name that I could save this as, and it's automatically going to place it into my equipment templates in my project folder for my Plant 3D project. So I'm going to give this a name. We'll say this is KETIV vessel. And once I'm okay with that, I'll click save. Now that has actually been saved as a template. I'll show you how to bring that in. But one thing before I bring it in, I do want to state that when you are creating these templates, you are authoring all your nozzles fully. It's probably best to author everything. If you have multiple nozzles, author all the nozzles and then save it as a template. This case, I only have 2 to author, so it's fine. Now I'm actually going to go ahead and create equipment in the same ribbon tab. Now from here, I could utilize the templates that are in Plant 3D, but I did create a custom template. So if I go to the bottom left corner and go to templates, I can select KETIV vessel, and this is the vessel that I just created. I could actually give this a tag number if I wanted to. So I'm going to give this a new tag. We'll say 101. And then I could assign it that tag number. And then this is where I wanted to show you that the properties that I did place in Inventor are actually going to import with it as well. So when I go into this properties tab, I could actually see that a long description has been defined as KETIV vessel. The manufacturer, ASME, I did put that into Inventor. Short description I give is 1000. So those properties that you do put into Inventor will come over here. Now that I have checked that, nothing else here, I'll click create. Now from here, it's going to specify the same insertion point that I selected at the bottom, and then I'll place one here. I could determine my angle. If I wanted to, I can place another one too. Click create. Oops. See vessel. Give this a number of 2. Assign. Create. So that's how I would actually utilize these parts or these assemblies that I am converting into Inventor, that I actually shrink wrap using a level of detail, substitution level detail, and then push them into a BIM content, and then brought those over into Plant 3D so I could utilize these and route piping off of them. Now note that because I did author these authoring remained within that vessel. So as I stated before, before you create these templates, try to author all your nozzles or any connections that you're planning to route off of. That is basically it that I had for today. We are going to move into question and answering.
Yeah. Okay. Awesome. So yeah, let's move on to questions, Jeff. I know there's some people who need a little bit of clarification on a couple of things, so I'll make sure that gets squared away. So for those of you who do have questions, go ahead and type those into your respective chat panels now, or if you have, we already have them, and we'll go ahead and
So let me go back into the PowerPoint.
sort. Let's take a look here. All right. So just a general question, right? Is Plant 3D versus Inventor Tube and Pipe? What do you use when? What do you prefer using? What is, rule of thumb on use case?
So I actually do come from the tube and pipe background as well within Inventor. Inventor tube and pipe is actually very beneficial as well. You could get detailed part lists, but you could get that as well in Plant 3D. It all kind of depends on the complexity of the piping you are designing. If you are designing large facilities that you need to connect piping between buildings, I would utilize Plant 3D for that. If you are maybe designing just relatively small skids or something like that, something in the size of the example file that I had, I would probably design that in Plant 3D or in Inventor. But you could actually utilize Inventor too for this design. So if you wanted to design all your piping in Plant 3D, you could actually, for the structural assemblies, you could actually create shrink wraps of those. And then you could bring those in as the same method I showed you here, bring those into Plant 3D as your base, and then you could route your piping off all your equipment that you are bringing into. So if you are designing structural equipment, which I prefer to design structural equipment in Inventor, I would design that in Inventor. I would bring that structure into Plant 3D, and then from there, I would actually go ahead and route my piping from. So there's a couple different ways. It's kind of, I guess it's depending on the size and the intricacy of the detail that you're modeling. If you want to utilize Plant 3D to generate quick isometrics, that I would go with the Plant 3D side.
Yep. So if you need ISOs,
if you need ISOs and you're doing large scale ISOs with maybe hundreds to thousands of ISOs, you could utilize Plant 3D for that to automatically generate your isometric drawings for you.
Yeah, that's a lot better than.
Yeah. With the vendor side, you have to still manually, select your ISO run, open the drawing, place it into a new drawing, and then create, do the drafting work for the drawing. So that does take some time if you're dealing with over 100 type of ISOs.
Yep. But I mean, that's gonna take a long time regardless.
Yeah,
so
exactly.
Might as well do it in Plant. Let's see here. We got a happy Valentine's Day from Adam, who happens to be Jeff's cube neighbor. So yeah, happy
Thanks,
Valentine's Day to you too, Adam. It's ridiculous. Let's keep moving here.
Got anything else?
Yeah, is the BIM model, is it still linked to the Inventor model anyway, or is it kind of a solo file once you do the BIM export?
Is it linked? Yeah, it's linked because we created a level of detail. Now, if I broke the link and I made that a separate separate part, it would actually be completely independent from the model file.
And you're talking about the level of detail, or you're talking about
if I broke the
ADSK
link,
file?
The ADSK file? No, so the ADSK file is independent. It won't dynamically update. So if I change nozzles or change placements or orientation, you will have to publish a new BIM content part file. So that you do kind of lose that functionality, but it's
because you have to do a file translation.
Because you got to do a file translation. Yep.
Yep. So yeah, I mean, generally, right, you're gonna finish your structural equipment in Inventor anyways. Move it in.
Yeah.
So it's just an importation thing at that point.
Yeah, and like I said, you can author in Inventor and Plant. I believe it is 10 connections in Inventor, max still, and then I think it's about this. It's still 10 as well in Plant 3D, I believe.
For the number of
connectors. Yeah, for the number of connectors. I think
that's
Plant
all the MEP connectors combined, like mechanical duct and pipe and.
So, well, actually, that's a good question.
I haven't tried multiple types.
I haven't tried multiple types, but I have tried just nozzle connectors, and I believe it was only 10.
Okay, cool. That answers another question. Let's see. Looks like.
But I think Plant actually may be unlimited, so I think it's.
Yeah, we'll double check.
I'll double check that though.
Yeah. let's see
Any other
here.
questions?
Can you use the shrink wrap to import assembly files for step and SolidWorks files?
Yes, you can.
And then, like, I guess aside, or not aside, in addition to that question, can you remove holes and chamfers from things like SolidWorks files and step files? So that's a little more tricky.
That is a little bit more tricky because of
The nature in there.
the nature and how it's actually being. We don't control how the actual file is being exported from
or imported
even better from SolidWorks. So that's where you're kind of left in a loop right there.
Yeah, if the software recognizes it as a whole,
yeah,
like a circular thing that goes through something, it'll probably get rid of it.
Yeah.
I know that just because of the nature of how those files come in as quote unquote dumb solids, sometimes the face and edge detection and stuff is a little different than you would imagine it to be. So
and then with that too, Inventor has added that tool called AnyCAD, right? And AnyCAD, I know that they are working on being able to make it as easy as possible to bring those file types into Inventor, and then it will recognize those features within Inventor.
Yeah, some of them get recognized.
Some of them get recognized. Some of them I've seen that they don't really.
Yeah, it really depends on the use.
Yeah, it really depends on the model too. But you can bring in, so a lot of times when you are, like the previous company I used to work at, we would receive val files and they would be pretty intricate files or even compressor models too. And we try to remove all the bodies as much as the features as possible. So utilizing shrink wrap, you don't even need to do a shrink wrap in as a level of detail like I showed you. You could just utilize the normal shrink wrap where you'll generate a part file off of it as well.
And then it's not a level of detail at the
then it's not a level
assembly.
Yeah, exactly.
It's just
so the reason why I showed that level of detail within the assembly is because I actually wanted to use that level of detail within my main assembly. There's a couple different ways to do that. You could actually, what I've done in the past too was actually create a new level of detail, and then I'd actually have to manually go through my model, suppress out the parts that I didn't want, go through there and suppress features. It's just a manual type of process compared to just right clicking,
swapping a level of detail as opposed to swap components.
Exactly.
Yep. All right. Let's see here. I'll give everyone another 30 seconds or so to ask any more questions that you do have. Looks like we're getting more happy Valentine's Days for people. I guess people like you, Jeff. So, all right.
Anybody else? We got one from Germany.
Oh yeah, Jorg. Yeah, Jorg's here pretty frequently. We have a lot of customers, or not a lot of customers, a lot of viewers all around the world. So definitely for those of you who are ready to sleep, maybe it's like really late at night for you. Definitely thank you for joining us. I know that it might not be the most ideal time for some people.
Exactly. Or the Pacific.
Exactly. So before we let everybody go, I just want to make a couple of announcements for the next two AVAs. We had an AVA maybe 6 weeks ago with Eric Paul, who I actually share an office with, and he went over 20 productivity hacks in Inventor. Quick tips, to make modeling or performance better. Things like, shift hotkeys and random stuff like that. And it was super well received. You guys wanted to see more stuff. So I made him do another one. So next week, Eric's going to go over 20 more productivity hacks in Inventor. I've seen some of them. I helped him come up with a few.
Yeah.
I'm really excited. So definitely stay tuned for that next week. And then
I got one more too.
Yeah.
We are planning on doing one it's been requested to do tube and pipe.
Yep.
So we are going to do some tube and piping within Inventor. We have one of our other AEs, Cameron, who is going to be demonstrating that, I believe, right?
Yeah.
And then also for that, going back to that question about when to choose, we are going to tie that in with Plan 3D as well. So look for that in the future. We are going to talk about both, how each one can benefit each other. So the question kind of jumped at us a little soon. We are getting to that though.
Yeah, tube and pipe, Plan 3D. When do I use what?
When
how
do
do
you
you exactly?
The differences between the two, and we will touch on that.
Yeah, and for those people who do have things like the product design and manufacturing collection, you have both.
Yeah, you do have both. So it's something that a lot of companies don't tend to use. They have the software, they don't realize they have it, and when can they use it,
Yeah.
and how to use it. So we'll touch that.
I've seen customers, build an extrude of like a circle and then just extrude that, and build 90 degrees and stuff like that. It's
Yeah.
like, no, there's functionality to this.
Yeah.
So again, thank you everybody for being here. Jeff, thank you for being here.
Thank you guys for everything. Thank you for joining and watching, and
Happy Valentine's Day.
happy Valentine's Day.
We'll see you next week, guys. Bye.